Alright guys, so welcome to today's tutorial video. In today's tutorial video, we will discuss how this Gatling was made, alright? So this Bezier curve Gatling thing, you have seen in the last giveaway video. So, how did I make this, okay? But first of all, before we get into the details, I first of all want to tell you something, alright? So this Gatling right here has one flaw, and that flaw is that, look, when you face into this direction, everything seems fine, alright? So, it seems cool. Now, when you move in this direction, you have this. And I'm honest with you, I don't know how to fix this yet. I don't really know because I'm not that much into Bezier curves yet. And I also did not want to, don't do this video just because of this little flaw right here. So if you're able to fix it, then provide me with that solution so I can drop it on the channel and help out others. But yeah, so that's something I wanted to tell you. All right. So in general, what happens right here is that this Gatling local script right here is responsible to detect all of the controls. So when you press a certain key, this remote event right here will be fire servered. This fire server will lead this server script right here to react, and this reaction is going to be a fire all clients of this Gatling remote. This will lead to the reaction of this local script to this fire client, and this fire client was sent to all clients, means every player reacts within this Gatling visuals by creating the Gatling visuals, as the name suggests, alright? And these two assets are needed for the Gatling itself. Okay, so let's take a detailed look inside of this. So we have a variable called UIS, which is obviously the user input service, and there is this event called input begin, which detects when a user input has begun. It means when you have pressed a key or have input. Yeah, have just input something. So it can be anything. It can be a key, mouse button, a controller button, joystick, whatsoever. At least from what I know, right? But I'm not that much into controller input. Now, when this happens, we receive two variables. The first one is the input which was done. The second one is called game processed event, aka GPE. So that's just an acronym for that. And GPE basically tells you whether this input was done while interacting with in-game elements, such as the chat or an in-game shop, for example, or not. Alright, and if it's not GPE, then this input was not done while interacting with such elements. And we can conclude from that the input then was done on purpose, So it is a difference when you press Q right here while writing something in some kind of chat bar, for example, or when you press Q on purpose to to do this Gatling, okay? But both things would, in theory, lead to this Gatling to be created if you would exclude this GPE right here. That's the reason why we have it, alright? This part right here just makes sure that the input which was done is a key, and furthermore is the Q key, okay? And after that, we are referring to the replicated storage, and then to this Gatling remote, and then we fire server this with the task Gatling. Now, wait, this is already too much. Let's go inside of here. So, right here, we are referring to the replicated storage, and then to this Gatling remote, and then we call this on-server event. And this on-server event fires when this Gatling remote has been fire servered. And when this has been fire servered, we usually receive the player automatically. And those two are optional, but in this case, we have added. Yeah, we have added a value right here, a value, and the second value is not here, but it is inside of this Gatling visuals, alright? But we will take a look at the second value later on. So if val is to Gatling, then, as I've already told you, we are going to fire all clients. So we are referring to this remote once again, and then we are doing fire all clients with the task Gatling visuals and with the player as the second argument, and the player right here is the player who wants this Gatling to happen. All right, so this same player has just pressed the Q key to do the Gatling move. Means this player is the performer of the attack, and that's important when you handle the visuals on the clients. You have to determine who the target is and who the performer is. The target is actually optional, depends on what kind of attack you're doing, but you always have to determine who the performer is. That's important. That's the reason why we have added the player right here. Now, when we fire to all clients, this Gatling visuals right here is going to work, alright? So what happens exactly in here. So those are important for the Bezier curve, but we will get to this later. So right here we are once again referring to this Gatling remote, and then we are calling this onClient event. And yeah, so this onClient event usually gets two arguments. The first one is the value, which is this one, so Gatling visuals. The second one is the player. The performer, I'm sorry, the performer, okay? So if the value is to do Gatling visuals, we could actually exclude this. So we could get rid of this because we're only using this Fire client once, okay? In comparison, we are using a Fire server multiple times. Therefore, it is very, very recommended to use this value right here. But on the other hand, we can we can really leave this, all right? And by leave I mean remove it. We could, but I'm too lazy to do it. So what happens when this local script right here is supposed to do all of the Gatling visuals? So the performer, first of all, is unable to move because the walk speed is at 0 and the jump power is at 0 as well. And then I have set up a table which requires it does not require anything. So it holds the name of certain body parts, alright? And those body parts, as you can see, are the left upper arm, the left lower arm, the left hand, and all of the right arm body parts, alright? So left arm and right arm body parts are contained inside of here, and they equal 1, okay? The problem, or the idea behind of this, is that when I remove this, I'm unable to index this like this, all right? So I'm unable to do so. Therefore, I have to assign a value to this index, and it doesn't matter what kind of value it is. I could have entered something else as well. Nah, maybe not this, but something like that, all right? So any random number, or I could do nil. You know, I could have done anything. So that I've picked one is actually a coincidence in this case. But you know, we just need this value to be able to index this index right here, like this. Now, what happens down here is that we are looping through the character via getChildren, alright, that's important. And then we are basically checking if, so V becomes one of those body parts, and we want to check if V, so basically if the name of this body part we are currently at, because we are looping, is contained inside of this table. That's what is expressed right here. So if BP has an index which equals the name of the body part we are currently at, because we are inside of a loop, then we want to turn the transparency of this body part to 1, means to invisible. So what we're doing, to once again repeat this, we have a bunch of right arm and left arm body parts right here. We are checking if they exist inside of that character, and if they do, then we set them to transparency 1, means to invisible. So I could have also just done the following. So I could have done performer.character.left upper arm .transparency equals 1, and then so on with all of the other body parts. I could have done that, but I wanted it to be automatic, so that, you know, so I don't really like to do things manually, so I like to do them automatically. That's the reason why I've done this way, which is surely, yeah, complicated to understand maybe, but yeah, that's just how it is. Now right here, we are referring to our performance character, and then to the humanoid, and then to the animator. And this animator instance is responsible to load the player animations, alright? So that's the reason why we have this load animation function right here. And inside of this function, you have to refer to the animation you want to load. And in this case, the animation is script.gatling, so this one. And this one is going to be this Gatling animation where the performer leans forward. And yeah. So after this was done, so after this animation was loaded, you basically receive an animation track. And this animation track can now easily be played. And playing this will result in playing the animation, obviously, alright? Now right here, we have set up another variable called doingGatling. And this one is, as the name already suggests, yeah, just telling the script whether the Gatling is currently being performed or not. Alright, and at the moment of this, we are setting this to true, means the Gatling is now going to be performed. Alright, and this literally happens down here, here, and here, until we get to this stage. Alright, but we are going to get to this soon, okay? Now, we have an if statement right here, And this if statement checks whether the player who is holding the script, who is the owner of the script, is also the performer. And that is important because down here we are making the camera of that player shake. So only the performer's camera is going to be shaken because we have this if statement right here at the beginning. Do you understand? Now, this camera shaking is going to last until doing Gatling is false. Or let's put it this way. So this code, which is the code for the camera shake, happens while doing Gatling is true. Alright? And that's the reason why we are putting doing Gatling to false, or why we are setting it to false down here. Because that will lead to this loop to end. Alright? And we have to put this inside of a coroutine, because otherwise this will yield the whole script, means it will pause the whole script until this condition is not met anymore. Alright? Therefore coroutine resume, and then we are creating another coroutine inside of this coroutine, coroutine resume right here. Alright, and this code, so we have x, y, and z, so 3 variables, and for each variable we get a random number in between 100, minus 100 and 100, and we divide this by 250. Alright, and the lower this is, so this 250, the more intense the camera shake is going to be. Alright, so just to keep that in mind. So if you want to adjust the camera shaking, then pay close attention to that. And down here we are setting our performers, characters, humanoids, camera offset to these 3 axes right here. Alright, and down here, once this loop is ended, we want to revert the camera offset. So that's important as well. Down here we have script.sound clone, so we are cloning a sound which is inside of here, and this sound is a Gatling sound. Alright, and we are putting this Gatling sound inside of the performers humanoid root port, and then we are playing this sound. So that's just to the Gatling sound right here. So this for I loop marks the beginning of this Gatling. Alright, and this is going to be a little bit more complicated in my opinion, but we'll hopefully get through this. So what happens right here is that we are setting up a loop which runs 100 times, okay, indicated by this. So it runs from 1 to 100. Now, we have added a wait right here to, you know, to have a small delay in between each arm. Otherwise, when we remove this wait, all of the arms are going to fire in an instant, and we do not want this to happen. Wait, is my computer seems to lag. Wait. I don't know why. I hope that OBS is not lagging. Alright, so when we remove this, all of the arms will spawn in an instant. I'm not going to show you how this looks like because that's unnecessary, but let's just move on. So we now have set up this ray settings right here. So raycast params.new. You can consider this as an empty template of a ray. Alright, of a ray setting. So when you guys know about raycasting, alright, so let me quickly show you what a ray is. Alright, so you can imagine the ray as something like this. Alright, so a small line which has a starting point. So pretend that this is the starting point, and then it has an ending point somewhere. And wait, so where is it? Yeah, this is the starting point, and this is the ending point, and the third argument are the settings. Alright, and we are just setting up an empty template of those settings, and then we are filling this template with some settings such as the filter type, which is going to be a blacklist, and the filter descendant instances. So those are the instances which are going to be filtered out via this blacklist concept, and those instances are every descendants, or every descendant of our performance character. Now let's get back to the ray. So the ray, as I've told you, has a starting point and an ending point, and you can literally imagine the ray as some kind of line like this, alright, which is of course invisible. And if something touches this ray, so let's say a person walks through this, then this ray is going to be triggered. Alright, so this happens right here. So if ray, so this is basically the case when something has touched the ray. Okay, now in our example, the starting point is at our performer's humanoid root port's position, and the ending point is at our humanoid root port's our performer's humanoid root part's look vector multiplied with 15. So 15 studs from the direction our performer is looking towards to. And yeah, so if ray, so if something has touched the ray, and ray.instance, alright, so this is important. Ray.instance is the instance which has touched this ray. In most of the cases, this is either, let's say, some kind of object such as a wall, a tree log, or what else, alright? So some kind of object like that, or it also can be a body part of a dummy or a player's character, okay? So you can divide in those two cases, okay? Either it is some kind of dead object, which is only, yeah, let's say some kind of part of a map, or in the other case, it is a player or an NPC, okay? And ray instance can be a body part of them. So the second argument right here, second requirement, make sure that ray instance, so a potential body part or wall part, let's say, the parent is a model, okay? So why do we do that? Let me explain this to you. So what is the idea of adding requirements right here after this one? So the idea is that with this ray, we want to see if a person touches this ray while we are performing this Gatling. So we want to check if there is someone in front of us who we could potentially hit with that Gatling, okay? So it is about finding someone who you can deal damage to. And those requirements will help us to see if this object, this instance which has touched the ray, is a body part of an NPC or a player, okay? So, ray instance parent is a model. That's the first requirement. Is this instance inside of a model? This is literally what is being expressed right here. At this point of time, it can be a body part, such as the upper torso, the lower torso, the left upper arm whatsoever, or it could be an object of the map, which is inside of a model. Okay, those two cases are still valid until to this point. After this third requirement, only one case is valid. So ray instance parent find first child humanoid. This checks whether this model, in which this ray instance is located into, contains a humanoid. All right. That's what is being asked for right here. Now, you could possibly argue, yeah, so when I have a model in my game, which is a part of the map and which contains a humanoid for whatever reason, then we would be able to trick out or to trick this part right here. All right. Yeah, you would be able to, but what kind of map object has a humanoid inside? I can only come up with one, and that would be a ship. But I think that people back then did it or have done it that way. Okay, I don't know how people approach the idea of creating ships today. So whether they still use humanoids or not because of the health, but I don't think so. I think there are better alternatives out there to do that. So just make sure that your map does not contain objects which are inside of models and which have a humanoid at the same time. Otherwise, you're going to confuse this ray right here. But let me explain you something. So the case I've just described, so that you have an object which has a humanoid inside, so that case is very, very unlikely to happen. Therefore, you can forget about it, alright? So if all of these requirements are met, so if we have found a potential enemy, then we are going to fire server this Gatling remote right here with the task Gatling damage and ray instance parent. Okay, and then we are going to go back to this one called Gatling server, and as you can see we have another case right here. So else if value Gatling damage, then we are right here, as you can see. So ray instance parent, so this one is a target, alright? So this one is the model this body part is inside of. So value 2. And what we're doing right here is that we are comparing distances. So the distance of the target's humanoid root part's position and our humanoid report's position. So we take the distance in between both of them, and then dot magnitude converts this into one number. And if this number is smaller or not greater than 20, and this target or this target model does not contain something called Gatling damage cooldown, then we can proceed. Let me explain you why I'm checking for distances again, because we have already done this raycasting stuff, so why would you check for the distances again? Let me explain it to you. So this thing right here is client-sided, alright? And you have to pay very close attention when you work with information which you have received from the client, because that information could possibly be exploited, corrupted, spoofed. So exploiters could just give you fake information if they want to. Therefore, you have to check it on the server again, and that's just one way of checking it. So exploiters could possibly exploit this as well. So this part right here. Nah, wait. I'm not sure if they could, but well, if you give them enough time, they would be able to. Now let's just move on right here. Now wait, I already have an idea on how they could exploit this. So this ray right here, all right, this only gets a person who's in front of you. You could literally just fire server as an exploiter, all right, fire server this Gatling remote with each player who's nearby you, but who's not like in front of you, all right. So you don't hit them with the Gatling, but they are still nearby. Okay, so you could get all of these and then run this fire server with their character model inside of here, and then this check would be valid and they would receive damage, although they would not been or yeah, although they're not in front of you. Okay, so that's in how they could exploit this. Yeah. All right. So down here we are creating a new int value inside of this target model, and we are calling it Gatling damage cooldown, and we are destroying it after 1 second. And after that, we are dealing damage to the humanoid of this target model, and this damage is a random amount in between 5 and 12. All right. So you can change the damage inside of there if you want to, and you can lower this to reduce the cooldown in between each damage, let's say, alright? Because if we would not add a cooldown, then the player would instantly die, or the target would instantly die. That's the reason why we do so. Now right here, we are working with the Bezier curves. So I'm not an expert when it comes to Bezier curves, but I can try to explain some stuff, alright? So when you work with Bezier curves, you guys probably know how it works, but I'm still gonna explain it to you. So you usually have a start point, an ending point, and the middle point, alright? And depending on how this middle point is positioned, your Bezier curve changes, okay? So if you have no idea on what I'm talking about, then go ahead and check out some Bezier curve tutorials on YouTube. There are a lot of them, alright? But nobody has done it on the Gatling yet, therefore I'm the first one to do so, okay? So the starting point is first of all, we're changing the starting point down here regarding the direction of our arm, but we'll get to this soon, alright? So at first, the starting point is at our humanoid root part C frame, okay? And pay attention, this is the start C frame, not the start position yet. Okay, now down here we have already defined the goal, which is the start C frame multiplied with another C frame, which moves minus 7.5 on the Z axis. Means we are moving to the front, all right, and we are converting this. Wait, how is this possible? Wait. Do we? Okay, that's actually funny. Yes, so this position converts all of these, as it seems, into a vector 3. Alright, and that's what we need. Alright, so down here we need vector freeze. So make sure that when you're working with C-frames, to put them in position afterwards. And this middle part, as I've told you, has to be in between the goal and the start C-frame. And that's literally what happens right here. So we are setting up a new C-frame, which uses now, or which you know, puts the so we are adding the start C-frames position, now the X position of our start C-frames position, to our goals X position. Then we divide this by 2. So that's how you get the middle in between, all right? And we do this for each axis, so Y and Z as well. And remember, those are only the start and the goal and the middle at first. We are editing them down here according to their direction. So next variable is dir, which stands for direction, and it is just a random number in between 1 and 2. Alright, 1 is declared as left, else means dir 2 is declared as right. Alright, so just so you guys know. Apart from that, we have another variable called angles, which is 0 by default. So see from that angle 0, 0, 0. And we are we are also changing this down here, as you can see, okay? But we are going to get back to this soon. Now, next variable is the color, and it is really black by default. And we need this color because, you know, because of the Gatling arms, so to influence their color. Now, if direction is 1, means left arm, then what we want to do is that we want to change the color to our performance left upper arm brick color. That's the first thing. Apart from that, we are editing the start C frame. So we use our start C frame as the base and multiply another C frame to it. And this is just randomizing the starting point, as you can see. So -4 to 0. So we generate a random number from -4 to 0 for the x-axis, and from -1 to 1 for the y-axis, and -2 is always constant. All right. So for the z-axis, right here, we are also influencing the goal. So the goal point, the ending point. So goal equals goal plus, and then some random vectors right here. We do the same for the middle. Yeah. And the angles, they stay at C frame, they're at angle 0, 0, 0, okay? Now, right here, sorry, I had to go AFK, so same thing happens for the right arm. We take the right upper arm's color, we have some random C frames to each start, goal, and middle point, and this time we are setting the angle to this, alright? And this rotates the right arm so that it looks like a right arm. So the thing with the left and the right arm is that they're not the same when it comes to the angle, alright? So the left arm has a different angle as the right arm, and they do not have the same angle if you think about it, alright? But I think that this should be obvious, okay? So right here, we are referring to something called ring shockwave inside of the replicated storage, and we are cloning this one. We are putting it inside of the workspace. So this ring shockwave is, as the name suggests, a ring shockwave, which is white, which is neon, which is anchored, can collide as faults, and we are setting the C frame of this ring shockwave to the start C frame. Then we multiply this with a certain angle so that it actually fits, you know, and we multiply this with another C frame as well, which makes this ring shockwave stay a little bit behind, so at the back, or a little bit more in the front, so that is actually random. And right here we are creating a tween. So what a tween does, just to briefly describe it, is that it transits an instance from one state of property to another state of property. So when you have an instance which has transparency 0 for the moment and you want it to have transparency 1, then what the tween subs does is that it creates some kind of transition which goes from 0 to 1. Okay, so I hope that this was understandable. In this context, we want this tween to be applied on this ring shockwave, and we want the transparency to go from 0 to 1, and we want the shockwave to double its size. All right, and we are making this tween play. After this tween is done, we are destroying the shockwave, and after the shockwave, now after everything right here happens, we are once again referring to something called Gatling arm, and we are cloning it. We are setting the C frame to the start C frame, and we multiply this one with the angles. All right, so when this Gatling arm is the left arm, then the angles stay the same. When this Gatling arm is the right arm, then the angle is different, and start C frame is as well different for both sides. You know, the brick color is being set right here. This Gatling arm is being parented to the workspace, and we are creating another coroutine right here. I don't even know why we are creating a coroutine for this. We don't really need to, so we could actually delete this as well. Yeah, we could. Yeah, we could. That's no problem. And this coroutine or former coroutine held a tween, and this tween right here just makes sure that this arm or this arm's transparency, it goes from 0 to 1. All right. And after this tween is done, which happens within 0.5 seconds, this arm is being destroyed. And we have another coroutine right here, and this coroutine does this Bezier curve magic. All right. So inside of here we have another loop, and this loop goes from 1 to 100, and it takes 0.5 steps. So you have to imagine that you start at 1, and with each loop, 0.5 is just being added onto the current amount of loops you have. So 1, 1.5, and then 2, 2.5, 3, 3.5, and so on. And down here, we are setting the C frame of each Gatling arm to a new C frame. And that's important. So we are using this quad right here, okay? And this quad uses these amount of loops right here, which go up in 0.5 steps. So right here, and we divide this by 5, and then we add the start C frames position, so the start position, the middle position, and the ending position or the goal position. And apart from that, we are also applying the Gatling arm's natural position, which is, you know, the performer's humanoid root part C frame multiplied with another C frame. Now wait, no. I was shit talking. So this is about the way it is going. It is going to. Now wait. I've just confused myself. Wait. Now wait. So look, this is the direction it is facing to. Okay, and this is obviously an C frame which is in front of our player. So the Gatling arms face in front of our player. Okay. Now we add our angles right here to the C frame as well. And now right here we are checking whether the distance in between each Gatling arm and the goal is not greater than 1. And if that's the case, then we are going to break this loop. And yeah. Now this quad function, alright. So this quad function is up here, and it requires some kind of time unit, which is our I2 divided by 5, then a start, middle, and ending point, and then we have a bunch of math happening right here. So L1 uses this lerp function, and this lerp function requires 3 other variables, and then we have some kind of equation right here, so some kind of calculation which happens right here, and this is basically how it works, alright. So I can't really explain this because I haven't really dealt with it yet, but I know that it works, and that's enough. Okay, so L1 uses the start and the middle, L2 uses the middle and the goal, and this quad unites L1 with L2 so that we have start, middle, and goal in one. and this time unit as well, and then we return this quad, and that's basically, yeah, how this Bezier curve works, okay? So Red Plies, for example, has also made a video on Bezier curves, so go ahead and check it out if you want to. Check out the DevHub, entry for that, you know. So there are a lot of cool, let's say, blogs in which you can check out how Bezier curves work. Okay, this is just Bezier curves used on a Gomo Gatling, so some more practical stuff for you. Now down here, we are stopping the sound, we are destroying the sound, so the sound from earlier. We are setting doing Gatling to false, we are stopping the animation from playing, we are reverting the walk speed and the jump power, and right here we have this table once again, and this time we are just doing the same thing as above, but reversed. So we are setting the transparency back to 0, and that's it with the video, guys. I hope you have enjoyed it. If so, leave a like, subscribe, share this video to all of your friends, and me feedback in the comment section, guys. Take care and see you in the next video.